The Moon, Earth's only proper natural satellite. Well, at least the one which can be easily noticeable from the naked eye during the night. Not only this, but the Moon is also the nearest of all places where we want to build an artificial human colony. And the last time humans had crewed a mission to this natural satellite was in December 1972 with the Apollo 17 rocket. After that, NASA mounted multiple crewed moon projects, including the ambitious Constellation program in the mid-2000s, but none of them have gone the distance. But NASA's Artemis mission is here with the goal to send the first woman and next man to the lunar surface by 2024, this time to stay and build a moon base. So let's move right along and go ahead and discuss everything related to NASA Artemis mission in today's video of Discover Zen.
That's one small step for man, one giant leap for mankind.
50 years ago, NASA's Apollo program proved that it is possible to land humans on the moon and return them safely to Earth. Now is the time to return to the moon again, this time with the motive to build self-sustainable colonies. With the Artemis mission, NASA is aiming at least 3 missions to the lunar surface by 2024. The mission will include Artemis 1. This will be launched in sometime 2021 using an SLS rocket and Orion capsule. This is going to be an uncrewed mission. Artemis 2. This one's going to be a crewed mission and is expected sometime August 2023. The plan is to send 4 astronauts into the first crewed Orion capsule into a lunar flyby for a maximum of 21 days. Artemis 3. This one is the third planned flight of NASA's Orion spacecraft to be launched on the Space Launch System. Scheduled for October 2024, Artemis is planned to be the second crewed mission of the Artemis program, and the first crewed lunar landing since Apollo 17 in 1972. Now let's talk about the Artemis 1 in detail. Artemis 1, which was formerly Exploration Mission 1, will be the first integrated test of NASA's deep space exploration systems. The first in a series of increasingly complex missions, Artemis 1 will be an uncrewed flight test that's going to provide a foundation for human deep space exploration and demonstrate the capability to extend human existence to the moon and beyond. During this flight, the spacecraft will launch on the most powerful rockets in the world and fly further than any spacecraft built for human has ever flown. It will travel 280,000 miles from Earth, thousands of miles beyond the moon over the course of about a 3-week mission. Leaving Earth, the SLS and Orion will blast off from Launch Complex 39B at NASA's modernized spaceport at Kennedy Space Center in Florida. The SLS rocket is designed for missions beyond low Earth orbit, carrying crew or cargo to the moon and beyond. This is going to produce 8.8 million pounds of thrust during liftoff and is sent to loft a vehicle weighing nearly 6 million pounds to orbit. Propelled by a pair of 5-segment boosters and 4 RS-25 engines, the rocket will reach a period of its greatest atmospheric force within 90 seconds. After jettisoning the boosters, the service module panels, and launch abort systems, the core stage engines will shut down and the core stage will separate from the spacecraft. As the spacecraft makes an orbit of Earth, it will deploy its solar arrays, and the interim cryogenic propulsion stage, ICPS, will give Orion the big push needed to leave Earth orbit and travel towards the moon. From there, Orion will separate from the ICPS within about 2 hours after launch. The ICPS will then deploy several small satellites, known as CubeSats, to perform several experiments and technology demonstrations. On to the moon. As Orion continues its path from Earth orbit to the moon, it will be propelled by a service module provided by a European Space Agency, which will supply the spacecraft's main propulsion system and power. Orion will pass through the Van Allen radiation belts, fly past the GPS satellite constellation, and above the communication satellites in Earth orbit. To talk with Mission Control in Houston, Orion will switch from NASA's tracking and data relay satellite systems and communicate through the Deep Space Network. From here, Orion will continue to demonstrate its unique design to navigate, communicate, and operate in a deep space environment. The outbound trip to the moon will take several days. during which engineers will evaluate the spacecraft systems and, as needed, correct its trajectory. Orion will fly about 62 miles or 100 kilometers above the surface of the moon, and then use the moon's gravitational force to propel Orion to new deep retrograde, or orbit about 40,000 miles or 70,000 kilometers from the moon. The spacecraft will stay in that orbit for approximately 6 days to collect data and allow controllers to assess the performance of the spacecraft. During this period, Orion will travel in a direction around the moon retrograde from the direction the moon travels around the Earth. Return and re-entry. For its return trip to Earth, Orion will do another close flyby that takes the spacecraft within about 60 miles of the moon's surface. The spacecraft will use another precisely timed engine firing on the European-provided service module in conjunction with the moon's gravity to accelerate back toward Earth. This maneuver will set the spacecraft on its trajectory back toward Earth to enter our planet's atmosphere, traveling at 25,000 miles per hour or 11 kilometers per second, producing temperatures of approximately 5,000 degrees Fahrenheit or 2,760 degrees Celsius, faster and hotter than Orion experienced during its flight test in 2014. After about 3 weeks and a total distance traveled exceeding 1.3 million miles, the mission will end with the test of Orion's capability to return safely to the Earth as the spacecraft makes a precision landing within eyesight of a recovery ship off the coast of Baja California. Following splashdown, Orion will remain powered for a period of time as divers from the U.S. Navy and operation teams from NASA Exploration Ground Systems approach in small boats from the waiting recovery ship. Future missions. With the first exploration mission, NASA is leading the next steps of human exploration into deep space, where astronauts will build and begin testing the systems near the moon needed for lunar surface missions and exploration to other destinations farther from Earth, including Mars. The second flight will take the crew on a different trajectory and test Orion's critical systems with humans on board. The SLS will evolve from an initial configuration capable of sending more than 26 metric tons to the moon to a final configuration that can send at least 45 metric tons. Together, Orion, SLS, and the ground systems at Kennedy will be able to meet the most challenging crew and cargo mission needs in deep space. Now let's look at the spacecraft and different vehicles for the Artemis mission. Launch vehicle. The rocket that gets everything into orbit and heading to the moon. SLS will be used as the launch vehicle. Command module. The place where astronauts stay during most of the mission. This is needed to be as sturdy as possible because it is used for both ascent and re-entry into the Earth's atmosphere. It should be configured in a way that in case of an unexpected event, it can abort and keep every crew member and astronaut safe. It is designed by Lockheed Martin and the European Service Module, ESM. Capable of supporting a crew of 6 beyond low Earth orbit, Orion can last up to 21 days undocked and up to 6 months docked. Lunar lander. This helps astronauts land on the moon. This needs to be very lightweight because sending 1 kilogram of mass to the moon requires almost 200 kilograms of rocket to get there. On April 30th, 2020, NASA Administrator Jim Bridenstine announced that 3 American companies have been selected to design and develop a next-generation lunar lander, intended to take American astronauts back to the moon by 2024. As part of NASA's Artemis program, NASA will select 1 company's design to act as the designated lander for this program. These companies include SpaceX, Blue Origin, and Dynetics. SpaceX will utilize their already in development single-stage design, affectionately known as Starship. Originally proposed as the Big Falcon rocket, or BFR, SpaceX began initial concept work on the Super Heavy launch vehicle in 2016. The original intent was to receive funding for a future private space venture known as #DearMoon. The company is currently building and testing their serial number 10 SN10 Starship in Boca Chica, Texas. One of the ship design attributes calls for a type of in-space refueling, utilizing 2 separate Starship vehicles. But before Starship can ferry humans to the moon, SpaceX is going to need to perform an uncrewed test landing before a fully integrated lander can be certified to transport astronauts to the lunar surface. In order to transport Starship to the moon, the company will use its Super Heavy rocket first stage rocket, which is currently in development. Dynetics, a Leidos company of Huntsville, Alabama. they are developing the Dynetics human landing systems, which will include contributions from several partners. The unique low-slung crew module calls for horizontally acclimated drop tanks during descent to the lunar surface. The lander will feature a flexible array of launching and docking capabilities, as it will be able to utilize NASA's Space Launch System or the United Launch Alliance's Vulcan rocket. However, because NASA does not intend to use the SLS for the lunar landing program, it is very likely the craft will utilize Vulcan. Once in lunar orbit, the spacecraft will have the capability to dock to either NASA's Orion or the Lunar Gateway Space Station. Blue Origin of Kent, Washington will develop the Integrated Lander Vehicle, ILV, three-stage lander to be launched on its own New Glenn rocket system and ULA Vulcan launch system. Blue Origin will act as the prime designer and builder, alongside Lockheed Martin, Northrop Grumman, and Draper Lab. The three-stage architecture lander will consist of ascent, descent, and lunar transfer elements launched separately between Blue Origin's New Glenn and ULA's Vulcan launch vehicles. Much like Dynetics Lander, Blue Origin's design will be able to utilize Gateway or Orion for lunar docking capabilities. These were all about rockets and missions in brief about the Artemis program. Since NASA works under a government body, they have to rely on various political parties for much of their work to be completed. So we really hope that this mission doesn't get canceled, as much of the previously planned NASA spaceflight programs have. Now let us discuss, how is NASA different from SpaceX? Well, that actually sounds like something we should talk about next time on Discover Zen.